Okay, this video is going to be all 12 Module 2 questions from the 2017 set of released items. Okay, so skip around if you need to, but as always, I feel like I'm going to say this 1,000 times making these videos, but make sure to please give it an honest effort, at least read the questions first. Okay, number one. Number one gives you a table, and it's very important to realize that they're calling the t variable, and it's representing the number of terabytes, and this column is the c variable, which represents the cost in dollars. And essentially they want you to figure out which equation matches the table. Now some of you might just be able to not use common sense, I guess, but just basically pick the correct equation based on, well, which equation has 3 for t and 240 for c. It would plug in to make that equation true, and so would plugging in 4 for t and 315 for c and 5 for t and 390 for c and 6 for t. So I think some people are just very good with like these kind of table patterns, and you can figure out, what you, well, maybe I should put it this way. What do you do to 3 to make it 240, and what math do you do to 4 to make it into a 315? And it's the same math. What is it that you would do on the 5 to make it 390? Some people are just very good at patterns and tables, but I would contest that if you are given a table and you're asked to figure out the equation, or really anything, like if they give you a table, I would say that you should think of it literally as a bunch of ordered pairs, which would make it a bunch of points on, say, a graph. So this table actually gives 4 different ordered pairs that you could think of as 4 points, okay? And think about it. How many sets of coordinates, like how many ordered pairs, how many points do you need to know in order to construct like an equation of your line? And the answer is 2. You only need really 2, all right? And so they gave you 4. Like they gave you more than enough ordered pairs to make an equation of a line. And so let's do it that way. And what do you start with first? Like when you're given 2 points, don't you find the slope first? And you're going to go with the formula for slope. And I'm just going to use, shockingly, I know, I'm just going to use the very first 2 points, and so it's going to be y2 minus y1 all over x2 minus x1. So we're talking 315 minus 240 all over x2 minus x1, and so that would be the 4 minus the 3, and so this should be 75 over 1, which is 75. So my m value, my slope of all these ordered pairs, is 75. Now, just taking a pause right there, look at the choices. A versus B versus C versus D. These are very kind solutions because I already know the answer is D. Because choice D is representing an M value of 75. Look, MX, but in this case it's a T, but MX plus B. Okay? So I guess just not getting confused by the fact that your C is like your Y and your T is like your X, but M is 75 and it's D. So I could be done right now, but as usual, I want to be like extra thorough and just make extra sure, and at the same time review some important skills and processes. And what would you normally do after you already had M? What else do you need, and what do you do next in order to make an equation of a line? Well, I'm going to go with this. This is a good formula to know about, and this formula creates an equation of a line as long as you know slope and the coordinates of one point. That's why we call this point-slope form. Okay, so we're going to look to plug in an x-coordinate in here, a y-coordinate in here from just one point, and we have 4 of them, but we're just going to use one. And of course, what plugs in for M is our slope. So I'm going to pick, what I was calling x1 and y1 already, so 3, 240. So now I'm going to extra, zero in on the 3, 240. So that's going to be y minus 240 equals 75 times x minus 3. And in order to make this look like one of the choices, we're going to have to distribute to clear the bubble. And so we get y minus 240 equals 75x minus, what is 3 times 75? 150, 225. I should probably not be doing that in my head. So I'm actually going to take a moment to double check that. You shouldn't do things in your head. It's too risky, and you shouldn't do too many steps in your head at once. Don't try to hold too many steps in your head at once. Write the stuff down, pretty please. And then the last thing we would want to do in order to make this equation match one of the choices is add 240 to both sides, essentially getting y by itself, or c. And so negative 225 plus 240, that's going to be, shockingly, plus 15. So that's just extra reason. It's just making extra certain, that it's D. Leaving no doubt that the answer is D. All right, moving on to number 2. Number 2, again, hopefully you've already read this and stuff. But number 2 is basically just asking which graph represents a function. All right, look, reviewing this concept, if you want to figure out if a graph is a function or not, it needs to pass something called the vertical line test. The vertical line test says that if you can write or draw a vertical line anywhere on the graph, and the vertical line will only touch the graph one time, no matter where you put it, then it's a function. So looking right here, look at this. I can already see that, look, with option A, the vertical line, look, see how the vertical line is only ever hitting the graph once? So right now I'm going to say it's A, but as always, we want to be extra sure. So look at B. See how the vertical line is touching the graph twice in so many spots? And so that's a fail. And this one being a little more, like see right there, that vertical line is hitting the graph more than once, okay? Because those are solid points. Side note, if this was, say, an open point, then the line, this vertical line that I'm sort of just moving around, wouldn't actually be hitting it. But in this case, yeah, fail, 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 all kinds of fails. And then over here, see right there, that's actually a fail. That counts as hitting the graph more than once. That counts as hitting the graph more than once, all over the place. So it turns out that the answer is A, like we thought, but it definitely is good to make sure and don't just ignore all the other choices just because you think it's A. All right, this next one talks about the range, and you definitely need to know that the domain of relations is the set of all x's. So the domain is the set of all x's, but the range is the set of all y values or y coordinates. Okay? Now this is super straightforward because when they give you a relation in this form and all these ordered pairs again go x, y, x, y, x, y, x, y. And so if you just put all those y values in their own set with only the y's, that would be, it looks like A. They put them in order, which is normal. It's normal that they put all those y values in numerical order from smallest to greatest. And yep, A. That's it. The range is all the y values. The domain is all the x values. Number 4, this one is also very straightforward. You definitely, let me write it over here. You definitely need to be aware of the advantages of an equation being in that form, y equals mx plus b. Because that's very easy to make connections to the graph, where you can see on the graph what the slope of your line is and what the y-intercept is. So again, just to kind of make sure that I'm being very thorough with that review, you got to know that the m value means slope, and that the b value means the y-intercept, and the y-intercept is where your line is going to intercept your y-axis. And you can clearly see, look, that where this line is intercepting the y-axis is at -4. You could then look at this and go, well, that narrows it down to A and C right away. Which, sure, let's even do that. So it's definitely not B and it's definitely not D, just based on which equations have the correct y-intercept, just from looking at the graph. Now it's a matter of, does this line have a slope of 2/3 or does it have a slope of 3/2? Remember, slope is rise over run. Okay? Now looking at this one very carefully, I could see like another nice point to kind of like count between is that one. So being very careful that all these boxes are actually worth only 1 each. So 1, 2, 3, 4, yep, -1, -2. What I'm doing is sometimes they'll try to trick you and mess you up by having like every box worth 2 or have every box go by 5 or something. You got to be really careful counting off your slope or calculating your slope when they try to like make a different scale for your x-axis and y-axis. But this is like normal. It just goes by 1. So up 1, up 2 for your rise, over to the right 1, 2, 3. So that's a rise of +2 and a run of +3. So that means A. And again, in normal time, that this problem will take you way less time than it did for me to fully explain it. So it's very straightforward, just figuring out M and B and matching your M and B, slope and y-intercept, from your graph to your correct equation. Number 5, this one talks about rate, okay? When they talk about rate, okay, you got to be ready for the fact that they probably are talking about slope. So in a way, on the keystones, when they talk about rate, they might as well be talking about slope. Okay? Now there's plenty of ways to think your way through this problem, and hopefully you've already read it. If not, always pause the video and make sure you read the question and you think about it before just listening to me. So here we go. Have you read it? Good. So 2 problems every 5 minutes. At this rate, how many math problems does a student complete in 65 minutes? Again, there's plenty of simple ways to think your way through this, but something I'll choose to write down and stuff, and especially when it's like rate means the same as slope, okay? Again, rate and slope go hand in hand on the keystones, those words. And slope is a fraction. So 2 problems every 5 minutes. It's almost like they're trying to say, that fraction of 2 over 5, what would be the value over 65 minutes? Which essentially makes something called a proportion, and we can even say that this is just like x, and we can like solve for x, and cross multiplying gives us like 2 times 65 equals 5 times x. 2 times 65 is 130, I believe. Again, please don't do things in your head. Double check on calculators and stuff. And then to solve for x, we would divide both sides by 5. And I'm going to follow my own advice just to practice what I preach. 130 divided by 5 on my calculator gets me 26. All right, so it would actually be 26. Again, there's a lot of different ways to just think your way through that, going like, well, 65 minutes is 13 different times we went through 5 minutes. Like, I bet a lot of you have already just like, Mr. Falk, shut up, that's all we have to do. All we have to do is think about how there was 13 groups of 5 in a span of 65. So it was like 13 times we were able to do 2 problems. Duh. And that gets me 26 total problems. But, usually a lot of different ways to do these types of things. Number 6, read the problem first. Pause it if you have to, as always. All right, again, they give you a table, and they're talking about a rate, I think. I don't know if they actually say the word rate, but Sonia's baking cookies, and they give you a table. And it's actually very nice that these values are only making jumps of 1. It's very easy to figure out the rate or the slope, okay? And essentially, you figure out the rate or the slope is that for every extra number of batches, we need what? An extra 2 1/4 number of cups of sugar. Again, we could like literally write out the slope formula. And I know mixed numbers are not the easiest thing to work with. I get it. There's ways around that. But if I were to literally write out that as like a slope formula, I would get 2 1/4, I believe, right, over 1, which is just 2 1/4. So that's really easy to kind of, that's a good start. And let's focus on what they're asking. They're asking how many more cups of sugar would Sonia use to bake 9 batches of cookies than to bake 3 batches of cookies. Make sure you read this kind of stuff very carefully, okay? They're asking how many more cups. So how many cups of sugar was for 3? Well, that was 6 3/4. Or in other words, maybe I'll just, if you don't like mixed numbers, you can convert them to decimals pretty easily. There's even calculator functions that do this kind of stuff for you. Ask me about this later if you want to. But as far as the 9 batches, all we have to do is keep this rate going. We keep adding 2 1/4. So 4 would be 6 3/4 plus 2 1/4. That should be 9 even cups of sugar. And so 5 would be 11 1/4. And then 6 would be 13 1/2. And then 7 would be 15 3/4. And then 8 would be 18. Correct me if I'm wrong. Let's double check that. I do not want to be wrong, I guess. So we're always adding 2 1/4. So 6 3/4, 9. Yeah. 11 1/4, 13 1/2, 15 3/4, 18. Okay, so that would make 9 batches. That would make 20 1/4. Or in other words, 20.25. Because 1/4 is the same as 0.25. Now remember, they want to know how many more cups. So I like how they threw that in there as like a trap, okay? But they're not asking how many cups of sugar for 9 batches. They're asking how many more did you need compared to like 3 batches. So I hope you realize that that implies you're going to subtract these two numbers and get what? I'm going to do this on my calculator for sure, just so I don't take any risks. So 20.25 minus 6.75, or whatever. If you're using mixed numbers on your calculator, that's fine. I get 13 and a half. Next. So this one, hopefully you've read it. If not, pause it and continue after you've read it. Okay, this one there, they give you a graph, obviously, and it's very important to pay attention to how the x-axis, is in minutes, and that the y-axis is distance in miles, okay? And the question is just that. So, for example, after 6 minutes, Carl would have rode or ridden, I don't know what the word is, I'm not an English teacher. So Carl would have rode a mile, like 1.25 miles after 6 minutes. Okay? So the graph is just kind of giving that. So anyway, the question says, what distance in miles is Carl from his house when he starts biking? Now, you got to be able to translate this kind of stuff. When he starts biking, doesn't that mean like when the time is 0, like when time has just started and time is essentially 0 minutes? So look at the graph. Look here when time is 0 minutes. So wouldn't that correspond to what's essentially the y-intercept, or just plain and simple 0.25 miles? So there we go. That's it. Number 8. Hopefully you've read this already and thought about it, and all they really want you to do is look at this scatter plot, and they want you to think about the line of best fit and what the equation of that line of best fit would be. And the equation, hopefully you notice that all these equations, I know I might not really need to even point this out to most of you, but all these different options are in mx plus b form. Nice. I mean, we like that. And all you really got to do is think about the line of best fit, the line that would go through these scattered points on this scatter plot. The equation needs to have the correct m and the correct b. Of course, for the 10th time, m is the slope and b is the y-intercept, okay? So that's all you really got to do. And if you're struggling to figure that out, let's see here. I would say that if you thought about the lines you were going to draw, I don't think the correct line that would go through the dots, go through the points, I don't think it's going to be A or C. Why do you not think it's going to be A or C? Well, if it was A or C, wouldn't the y-intercept b value need to be 0, Plus 0, plus 0. I think it's very safe to say right now, right away, that it cannot be 0. Okay? So it's either going to be B or D. And I decided, hey, why don't we just go ahead and graph them? So this red line, that's going to be D. So it's going to basically touch the y-axis at 40, and I already have that line preset as having a slope of basically up 15.7 over 1. It's not the cleanest exact, it's not like an exact science or anything, but it's basically like an estimation, okay, like I'm just kind of sketching it, and close enough. So this red line, that would be basically choice D. And this line would essentially be a representation of choice B, which would sort of cross the y-axis at about 29.2, basically 30, and it would go up about 11.8 over 1. So again, isn't it pretty obvious when you actually do it this way that The answer should be B. It has the correct M, and it has the correct B value by far. Number 9. Now that you've read it, this is talking about first quartile, third quartile, and you need to know what they mean. Okay? The first quartile represents, in other words, the lower median, or the median of only the lower half of the numbers. Okay? And the upper quartile, or as they put it, the third quartile, another word for that is the upper median, which is the median of only the upper half of the numbers. All right, don't think I need to write that, do I? So how do we actually take that and figure out the answer? Well, you got to remember this when it comes to medians and upper quartiles and that kind of stuff. You have to remember what a median is. A median cuts the data in half. A median is the middle number, literally. Okay, like it's the number that's in the middle and cuts the data in half. So if you were to talk about a median, of say, what could I say here? Let's say the median was like 4.9 minutes. That would mean that exactly half, or roughly half, okay, I don't want to go into too much detail, but you could say like maybe exactly half, or at least roughly half of the data was less than 4.9, and roughly half, if not exactly half, of the data is above 4.9. Now, what percent is half? You guessed it, 50%. So now if you take a lower median, aren't you cutting that half in half again, and therefore making like little groups of 25%? So let me cut to the chase here. Going through our options, if my lower median is 4 and my upper median is 6, let's see which choice makes the most sense. About 25% of the students completed the puzzle in 4 minutes or less. That actually sounds really good, because if 4 is the lower quartile, it's going to cut that lower half in half, and 25%. That sounds really good, but you don't just pick A. Let's make sure that none of the other choices make any sense. About 50% of the students in 6 minutes. Maybe if 6 was like the overall median, but 6 is the upper median. So no. C. And just to so part C, or choice C, exactly 25% of the students complete the puzzle in exactly 4 minutes? What? No. No, 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 no. And part D, I keep doing that. Choice D, exactly 50% of the students complete the puzzle in 5. No, no, no. That is no, no, no. You cannot even begin to like make that assumption. No, 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 no. So it's definitely A. Next. Okay. Now that you've read this and you've looked very closely at the bar graph and the fact that we have number of minutes represented on the, I guess, y-axis or vertical axis, and just all the different activities down here with Frank and his weekly activities. Let's see. Average number, okay, Dodoy. And down here, let's see what they're really asking. Which again, you should have read this already. But just let me get my bearings here. Which is the most likely, the difference in the number of minutes Frank will spend reading the next 4 weeks. Okay, hey, the devil's in the details, people. This is the number of minutes weekly. That means for 1 week. And so this definitely is talking about the next 4 weeks. That's important. And the number of minutes Frank will spend gaming online in the next 4 weeks. Okay, I'm going to get my calculator ready here. So, reading. Looks like Frank spends an average of 175 minutes reading every single week. So over the next 4 weeks, doesn't it make sense to multiply 175 times 4? And so we can predict that Frank is going to be spending roughly, this is why they said most likely, because who's to know for sure? This is like an average number. So sorry, not 7, it's 700. So that's a pretty good prediction how many minutes Frank is going to be reading over the next 4 weeks. And when it comes to gaming online, oh boy. Well, I'm going to estimate here, and I'm going to try to be, at least pretty close. And again, this is definitely kind of an estimate. I'm going to go with 120. Does that seem fair? 5, 10, 15, 20, 20. Yeah, whatever. I'm sure it'll be fine. I'm sure these choices are going to be not like super, super close to each other to where I could get in trouble with my rough estimating, but I think 120 is pretty darn good. So over the next 4 weeks, that should be 480 roughly minutes gaming. And so let's see, they want to know most likely I'm going to use a different color just for emphasis here, the difference, which means subtracting. So what's 700 minus 480? In other words, what's the difference between 700 and 480? Isn't it 520? No, it is not. It's 220. What the heck was I saying? See, again, people, this is why you just go to your calculator, which I will do now. What was I even thinking? 700 minus, 480. Yeah, that's going to be 220, you moron. So the difference is I got 220. So obviously the best answer from the choices is 224. What do you know? A box and whisker plot. Really? The Keystones want you to know about box and whisker plots? Sarcasm there. Hashtag sarcasm. You definitely need to be aware of box and whisker plots on the Keystones, for sure. So they give you so you've already looked at this, right? And the box and whisker plot's talking about the price of cars. So based on the box and whisker plot, where we know our lowest value of car, lowest price and our highest price, and the median and the lower median and the upper median are all given in a box and whisker plot, right? So which one is most likely true? Let's go through the options here, man. 1/2 of the cars are priced at $12,000. No. $12,000 is the median, and you could say that 1/2 of the cars are priced higher, as well as 1/2 of the cars are priced lower, but you can't say that they're priced at $12,000, so I'm going to say no. Moving on to checking B. All of the cars are priced no lower than $10,000. No, we know that the lowest cost or price is 6. So no, because again, the whisker goes all the way to 6,000, and that means prices go down to 6,000. So I guess if this number would have said 6,000, it would have been B, but nope. Choice C, 1/2 of the cars are priced between 14 and 25. 1/2? No. With 14,000 being the upper median, aka upper quartile, aka third quartile, you could say that 1/4 of the cars are priced, between the upper median and the highest one, but not 1/2. So it's not C. So it better be D. Better be. 1/4 of the cars are priced between 12,000 and 4,000. So yes, that is accurate, because between the median and the upper median, that is about 1/4, if not exactly 1/4. It's at least about 1/4. Because remember, when you take the overall median, it cuts the data in half. So we have like half of the data here, look, and half of the data here. And when you take an upper median, that's like cutting this half in half again. I know it doesn't look that way, but that's such a smaller, width than this. I get it, but that doesn't matter. It's still, when you do the upper median, it cuts this data in half. So that's like 1/4 or 25% of the cars, and this is 1/4 or 25% of the cars. So again, sorry to go long-winded again, but that's the point of these reviews. I don't want you just to review these exact 12 questions specifically, but the concepts and like any question in general, okay? Finally, number 12. Now, I'm assuming again you've read this already and looked at the line of best fit on the scatter plot. And look, gang, this is also classic Keystone type of question. They love scatter plots just as much as they like box and whisker plots. And so with scatter plots, just like an earlier question, you're going to want to figure out the equation of that line sometimes. But here, they want you to basically make a prediction based on the line of best fit. So again, based on the line of best fit, which is most likely the number of miles Julie would walk in 105 minutes. So we have minutes here, we have miles here, and so we're talking about, look, 105 minutes, and, well, I would say based on these nice dots, if you kept that going, bam, bam, and if you continued this line in that direction, you would get another nice intersection right there, which I think you can see is going to be exactly 7. All right, that's nice. Let me actually do that with my pen. There we go. So this was kind of kind to you, where you could actually see where this line was going to be for a future time of 105 minutes. Say, so we go up to here and over to here, where we're looking at 7. Again, I'm going to just use so bam, and then over to here, which is going to be 7. But what if they were going to ask about 200 minutes or 3? Like, what if they go like really far into the future, really far out of bounds? What would you do then? So allow me to just go off on a little bit of a tangent, I guess, and address what you would do if they were asking about 190 minutes or something crazy. In fact, let's get kind of crazy. Why the heck not? So let's talk about, what if it was 1,000 minutes? Okay, what if? What would we do? Well, here's what we could do. We could come up with like an equation and go from there. So, let me run through the motions quick. to make an equation of a line, we're going to want the coordinates of two nice points. And I'm going to choose this one. So this is 60, comma 4, and this was 15, comma 1. So when I use those coordinates to come up with a slope, that's going to be 4 minus 1 all over 60 minus 15, which is 3 over 45, which should reduce to 1 over 15. All right? And now that we have a slope and a point, we can plug into point slope form, which I'm going to use this guy. Y minus 1 equals 1/15 times x minus 15. Plugging in the 1 for y1 and the 15 for x1. And as usual, you're going to kind of like distribute and solve for y. So 1/15 x minus 1, and then add 1 to both sides. And I'm going to go over here on the left to make a final equation of y equals 1/15 x. And that's it. Plus 0. Plus 0. Which makes sense because isn't it obvious that our y-intercept is going to be 0 if this line went all the way to the y-axis? So there we go. So now now that we have the equation, here was my point. I'm sorry again, like this is just to make this clear. We were done with this problem a long time ago, just by eyeballing the graph, right? But another very, very, very effective method, especially if they've already like given you the equation for free, is using the equation, like I said. And if we wanted to figure out any number of minutes now, whether it's 105 or 106 or 90 or even something crazy like 1,000 minutes, since the number of minutes is basically your x value, I could literally replace the x and plug in 1,000 for x. So y equals 1/15 times 1,000, if that was the case. And so 1/15, I'm doing my calculator now, that would be about 66.6666, 66 2/3 miles. So that would have been the answer, like how many miles for 1,000 minutes. And you can do that by plugging in that value in for x. Okay? And that's it.